Welcome to Quant with Gil. So my name is Pushpinder Gill, and we're going to do the topic percentages today. So what I'm going to do is we're going to learn the concept of percentages. Then we are going to go ahead and do some practice questions on that. And for that, before starting, I would like you to note down my email address. This is going to be my email address, my personal email address, where you can contact me. And you can click on this link to go to our Facebook page. And do not forget to like us on the Facebook page. So my name is Pushpinder Gill. So let's go ahead and get started with it. So what exactly is percentage? It's usually symbolized by this sign here. You usually say, okay, 5%, 10%, 20%, right? So let's define what percentage really is. Percentage tells us how large or small a quantity is as compared to some other quantity, right? Now let's suppose John here. There are two persons who are selling oranges, right? Let's suppose John has 50 oranges and he's able to sell 30 oranges, right? So he had a total of 50 and he was able to sell 30 oranges. Similarly, let's suppose there is Brad here who also sold 30 oranges. However, he had 100 oranges with him. So if you look at the quantity wise, okay, both of them sold 30 oranges, that's fine. That means they're they sold equal number of, you can say, oranges. However, if you look at the percentage over here, he sold 60% of the oranges that he had and he sold only 30% of the oranges that Brad had. So percentage helps you to compare two things. Doesn't matter it's in quantity or it's in terms of quality, it will help you to compare two things. Why? Because it translates the base of any number of any fraction to 100, right? So percentage is kind of a fraction, but the base is always 100. So you have to remember that base of a percent is always 100. So this is the first point that I'm going to put emphasis on, that base of a percentage is always 100. Now let's just move ahead, right? So what do you mean? How do you say half? How do you say, what do you mean by half? You say always it's 50%, right? So how did half come to be 50%? So you just multiply half by 100, then you get 50%. Similarly, 1/3 of anything is going to be 1/3 into 100. That is going to be 33.33%. So normally you see some fractions around you. You see, okay, I did 1/4 of the work, I did 1/5 of my work, I did 1/7 of the work. So the fractions are always there. All you have to do is you have to convert those fractions into percentages. So how do you convert a fraction into percentage? It's simple. You just have to multiply the fraction by 100 and then you get the corresponding percentage. So fraction multiplied by 100. So if you multiply a fraction by 100, you're gonna get your percentage. Now this is some simple stuff, but it is very important for you to know that, because once you're able to understand the percentage topic deeply, you'll be able to solve any question that comes in front of you. Now if a child eats 6 out of 12 cakes, then he has eaten 50% of the cakes. So how did we find that a child eats 6 out of 12 cakes? So the fraction of the cakes that he has eaten is 6/12. That is equivalent to 1/2, and converting this fraction into 100 is by multiplying it by 100. I get my percentage to be 50%. So I hope you understood this. The scenario that I'm trying to teach you here is, whenever you get a fraction, you have to multiply it by 100 and you get 50%, right? So we did conversion of fraction to percent. Now there are some standard fractions which you can learn and do some calculations really quickly. In GMAT, in CAT, and in all these exams, you're not allowed a calculator. Even in GRE, the calculator slows you down. So what you need to do is, you need to learn some base fractions and convert them into percentages. So whenever you're solving a question, just with a click of mine, you can solve the answers. So what is half? Half, you always say it's 50%. Similarly, what is 1/2, multiplied by 100, I got 50%. So fraction into 100 is percentage. That's what we did. Now let's just look at some base fractions, right? So half is equivalent to 50%. 1/3 is equivalent to 33.33%. Now, how did I come to this? I just multiplied 1 by 3 into 100 and I got 33.33%. Similarly, 1 by 5 will be equivalent to 20% and 1 by 7 will be equivalent to 14.28%. 1 by 9 will be 11.11%. 1 by 11 would be 9.09%. And 1 by 10 would be 10%, 1 by 13 would be 7.69%. Then the next prime number is 1 by 17, that is 5.88%. Then is 1 by 19, that is 5.26%. Now, I do not expect you to learn this while you're watching the video. I just want you to keep a note of it, right? Because once you keep a note of it, you understand it, and slowly these things are in your mind. And whenever you see, okay, I need to calculate 1/3 of 600, I just divide 600 by 3, I get my answer to be 200. Similarly, someone asks you, hey, what is 14.28% of 700? You say 1 by 7 of 700, my answer is 100. So this is how, and now these guys, these are all the base fractions, right? So these are not the end of the world. Further, there are some derived fractions from this base fraction that we're going to learn from this method here. So 1 by 3 is 33.33%, right? So let me just write it down. 1 by 3 is 33.33%. What happens if I multiply the fraction by 2? The percent will also get multiplied by 2. So that means 2 by 3 will be equivalent to 66.66%. Easy, right? So whenever you have to calculate 66.66% of anything, just say 2 by 3 of it, then you'll be able to calculate it easily. Now let's do some derived fractions using this multiplication method. So 1 by 3 is 33.33. So 2 by 3 will be 66.66. 1 by 4 is 25%. So 2 by 4 would be 50%. 3 by 4 will be 75%. So 1 by 5 is 20%. 2 by 5 is 40%, 3 by 5 is 60%, 4 by 5 is 80%. So 1 by 11 is 9.09%, 2 by 11 is 18.18%, 3 by 11 is 27.27%, and goes on like that. So you can easily, quickly adapt to it, and you can easily understand what I'm trying to establish over here, right? So just get into the habit of using these fractions. Once you get into the habit, surely I just expect you to write all these base fractions and derive all the fractions in the back of your notebook, so they can easily flip at the back of your notebook and see. Once you're able to, once you start practicing, it will come to you quickly. Now I'm going to do derived fractions using division method, right? So what is 1 by 3? 1 by 3, again, it's 33.33%. What if I divide this fraction by 2? I'm going to divide this by 2 as well. So I get 1 by 6 to be equivalent to 16.66%, right? I hope everyone understood. It was pretty basic over here. 1 by 3 is 33.33%. So 1 by 6 is 16.66%. Similarly, 1 by 12 is 8.33%, right? Similarly, 1 by 9, it's 11.11%. Now, how did 1 by 9 come is, if you look at here, I divide this whole fraction by 3, this will also get divided by 3. So this is going to cut it at 11.11%. So 1 by 9 is 11.11%. So 1 by 5 is 20%. Similarly, 1 by 10 is 10%. 1 by 25 is 4%. This is really important, guys. You need to understand this. 1 by 11 is 9.09% and 1 by 22 is 4.54%. So see, you can easily calculate and derive these fractions all in all, so you don't need to worry about huge calculations coming in your way. So I would recommend you to pause the video and just jot it down. These are all the fractions converted into their particular percentages from 1 by 1 to 1 by 20, right? You can easily calculate more percentage as well, right? If you know 1 by 13, you will be easily knowing what is 1 by 26 is or 1 by 52 is. So it becomes pretty easy from here to calculate all the derived fractions from these fractions, right? So let's just move ahead and do keep a printout of this part over here. So Now, we have learned what a fraction is or what a percent is. Now, let's see what kind of statements that come into your questions. What kind of statements can arise? So, let's see, someone asks you 75 is what percent of 100? Then you simply say, okay, 75 by 100 into 100, right? This is what you do. You say, okay, it's 75%. This is one way of doing that. Or other way of doing that is, by just doing it in your mind, 75 by 100, if I cut by 25, it is equivalent to 3 by 4, and 3 by 4 is automatically equivalent to 75%. So this is something that you can easily do, right? So this is one type of percent. So if someone says to you, okay, X is what percent of Y? Someone asks you, X is what percent of Y? Then you simply say, it's X by Y, and if you want to convert this fraction into percentage, you just multiply it by 100. This is simple basic stuff that you must have learned in your high school as well, right? So the next is 80 is what percent of 160? You simply say it's 80 by 160, that is equivalent to 1 by 2, which is further equivalent to 50%, right? So it's pretty simple. Now, what is the statement type? This is the one which creates more problems. So increase 500 by 50%, right? So increase 500 by 50%. So how do you do that? So there are basically two steps involved over here. First, what you do is, I'm going to do it using two ways. The first way is, you find 50% of 500. All you do is, you find 50% of 500. That comes out to be, cancel this, that comes out to be 250. You calculate 50% of 500, and then you add that 500 to 250, and then you get your answer to be 750. Fine. This is the normal way that we are taught to do. But however, there is a quicker way and there is a much efficient way that you can do this thing. If you have to increase 50% by 500, so what you did is, you first of all, you calculated the 50% of 500 over here. You calculated the 50% of 500 over here, and then you added it to 500. Right? So what if I take 500 common out of the both terms? So what if I get 500 common out of the both terms? I get it to be 50 by 100 plus 1. Right? So this is what I call it the magic number, or usually it's known as the integrating factor. Right? So if you have to increase anything by 50%, let that be anything, it is always going to get multiplied by this number. Now I'm going to solve it more easy for you. If you solve 1 plus 50 by 100, it always comes out to be 1.50, right? So if you have to increase any number by 50%, you just multiply that number by 1.50, right? I hope you're getting it really easily, right? So you just multiplied that number by 1.50. Now let me just generalize what I did here. Let's increase y by x%. So what I do is, first of all, I calculate x% of y, and then I add it to the y. So every time I'm going to get this number over here, and this is going to giving me the new amount of y by increasing it by x%. So this is my integrating factor. So whenever I have to increase anything by x%, I just simply say increase that by 1 plus x by 100, multiply that number by 1 plus x by 100. Or if it's 50%, because if it's 50%, it's gonna get multiplied by 1.5, right? If it's 20%, it's gonna get multiplied by, if you calculate it, gonna get multiplied by 1.2. If it's 30%, it's gonna get multiplied by 1.3, right? However, if it is 4%, if you calculate, it is going to get multiplied by 1.04. So now your questions become so simple that you can solve anything very simply. Now this is type of statement that comes in many. It comes in profit and loss, comes in simple interest, compound interest. It comes in wherever percentage is involved. So whenever you have to increase anything by x%, you don't understand the expression, don't just cram it up, understand what I did over here, right? So this is now, we're going to work on the integrating factor over here. Now let's see what an integrating factor is. Now this is what we learned in the previous slide, that y into 1 plus x by 100 is equal to your product. So this is nothing but equal to your product. Fine. So y into the integrating factor is going to give you the product. So base, this is the base and this is the integrating factor and this is the product. Now why I have named it base? Because percentage increase means something is increasing and that something is your base, and whatever comes out is your product, right? So what if I have given you the integrating factor, I've given you the product, and I ask you to find the base? You can easily say base is equal to product by integrating factor, right? So this becomes more easy for you to calculate many things. Now this, guys, is very important because my methodology is based on this whole thing, the percentage topics, the profit loss, simple interest, compound interest, all the things are based on this expression over here, right? So you need to really understand it. I hope everyone understood it. The base, whenever you increase, this is about increasing, guys. Whenever you increase any amount by x%, right? So whenever you increase any amount by x%, this is what the expression comes out to be, right? Now what if I say you decrease amount? What if you decrease the amount by x%? So that becomes even more simple, that you just have to multiply it by 1 minus x by 100. So instead of plus, it gets multiplied by 1 minus x by 100 and then you get your product. So what if I have to decrease 200 by 20%? So I have to decrease 200 by 20%. So 1 minus 20 by 100 is 0.8. So the decreased amount would be 200 into 0.8, right? So I hope everyone understood this over here. So let's just move ahead to the next slide. Okay. So we're going to do that in the next slide, no problem. So let's do some practice, right? So first of all, we have to increase 500 by 50%. So I have to increase 500 by 50%. I simply say 500 into 1 plus 50 by 100, that is 1.5, right? Simple, okay? So I have to increase 700 by 14.28%. I simply say 700 into 1 plus. Now guys, what is 14.28%? It's 1 by 7, right? So that comes out to be 700 into 8 by 7. That is equal to 800. So if you have to decrease 700 by 14.28%, I'd say 700 into 1 minus 1 by 7, because 14.28% is nothing but 1 by 7. So that comes out to be 700 into 6 by 7, right? So I hope you're understanding this. It's very easy for you to solve the questions like this. It will become, you don't need to use a calculator now. So if I have to increase 800 by 25%, so I just say 800 into 1 plus, what is 25%? That is 1 by 4, right? So 1 plus 1 by 4, so that comes out to be 800 into 5 by 4. So I can calculate my answer from here, right? So similarly, if I have to increase 900 by 11.11%, so I'd say 900 into 1 plus. So what is 1 by 11, guys? You can flip to your pages. It's 1 by 9. So 1 by 11 is 1 by 9, and 900 into 1 plus 1 by 9, that is nothing but 900 into 10 by 9. So I get my answer to be 1000. Similarly, if I have to increase 900 by 88.88%. Now guys, let's calculate what is 88.88%. We have recently seen that 1 by 9 is equivalent to 11.11%. So if I have to calculate 88.88%, I'll multiply this number by 8, and this also would get multiplied by 8. So I will have is 88.88%. So 88.88% is equivalent to 8 by 9. So this is nothing but equivalent to 8 by 9. So that would be equal to 900 plus 1 plus 8 by 9, that is 17 by 9, and my answer is equal to 1700. So you see quickly over here that we are able to solve the sixth question, I say within 2 minutes, not more than that. You will take just 2 minutes to solve these questions. However, if you start doing using even a calculator, it's going to take you a little bit of time, because you will be increasing a number by a certain percent and then adding that percent to that number. So that takes a lot of time. So what I'm trying to show you over here, you can do all these calculations in your mind, so you don't need to do it on your paper, and you save time like that. So this is some time saving techniques on that. Now let's just form equations over here. Now let's just start forming equations, because it's all about equations in all these tests like GMAT, CAT, GRE. It's all about equations. So what you have to do is whatever kind of statements that you have done in the previous slides, you just need to use those statements and translate them into equations so that you can do your questions really easily. So over here, if John's salary is 25% more than Martin's salary, so what can you get from here? That John's salary is 25% more than Martin's salary. So John's salary is 1 plus, what is 25%? That is, guys, that is 1 by 4. So that is 1 by 4 of Martin's salary, or I can say that John's salary is equal to 5 by 4 of Martin's salary. Now let's just see what is he asking us. He's asking us by what percent Martin's salary is less than John's salary. So for that, we need to take this integrating factor to that side. So we need to take this integrating factor towards that side. So I can say that Martin's salary is equal to 4 by 5 of John's salary. So Martin's salary is equal to 4 by 5 of John's salary, and I can deduce this integrating factor into this. That is equal to 4 by 5 is nothing but 1 minus 1 by 5 of John's salary. So I can say that Martin's salary is 20%. 1 by 5 is equivalent to 20%. It's 20% less than John's salary, right? So this is how I can solve these kind of questions, right? So let me just do one thing from here. Let me just generalize all the steps over here. So if I say X is Y% more than Y, right? If I say X is Y% more than Y, then how can you calculate that? So the equation that is going to be X is Y%, that is 1 plus Y by 100 of Y. I hope you have understood this, because we have done it in the previous slides, that you can easily calculate if someone gives you this kind of statement. So X is Y% more than Y. Let's call it X is Y% more than Z. So X is Y% more than Z. So it comes out to be like this, right? So if someone asks you, okay, if X is 45% more than Y, then you can simply say X is equal to 1.45 of Y, right? So this is that you can easily form an equation like this. You don't need to do all the steps again and again, because even if a steps takes like 2 or 3 seconds, and if you're able to save like 30 steps like that, so it's going to save you like 90 seconds in a test, which is very crucial. So let's just move ahead to the types of statements. So the first type of statement is X is 10% of Y. So how do you tackle this? You can simply say that X is equal to 10 by 100 of Y. It's simple, right? Someone asks you X is 10% of Y. How do you translate it into equation? You say X is 10% of Y. Similarly, someone asks you X is 33.33% more than Y. Then you say X is equal to, now since it's percent more, so it will be 1 plus. So 1 plus, what is 33.33%? That is 1 by 3. So X is 1 plus 1 by 3 of Y. So if someone asks you that X is 33.33% less than X, less than Y, then you can easily say X is equal to 1 minus 1 by 3 of Y, right? So I hope you all understood what I did over here. So if someone says 40% of X is equal to 50% of Y, now 40% of X, that is equivalent to 2 by 5. 2 by 5 of X is equal to 50%, that is equivalent to 1 by 2, 1 by 2 of y, right? So this is how you can solve this questions. So guys, these are the three types of statements which are very crucial. You need to understand it. You can watch this video over and over again, because I suppose I've given you enough to understand the topic, right? So let's just move ahead. Now let's just see, when we use more than two statements, we make a kind of a statement trap. When I use whatever statements I have given earlier, we use a kind of a statement trap. Let's see what all kind of statement traps can come in your questions. So first kind of statement trap is the simple trap. That is, x is 40% of y is 70% of z, then x is what percent of z. So let's just break it down into some statements. So this is my first statement over here. This is my second statement over here. So I need to calculate this statement. So x is 40% of y, that means that x is equal to 2 by 5 of y, right? Similarly, y is 70% of z, that means y is equal to 70 by 100 of z. So what I need to do over here is, I just need to get this y's value over here. So I can easily calculate the relationship between x and z. So x is equal to 2 by 5. So instead of y, I'm going to write the value of y. 2 by 5 of, let me just cut the zeros over here so it's simple for us. 2 by 5 into 7 by 10 z, right? So this gets multiplied by 5. So x is equal to 7 by 25 z. So now we have this to us. Now we have to find x is what percent of y. So we have our integrating factor to be 7 by 25. So converting this into a percentage, I just have to multiply it by 100 and I get my answer to be 28%. So x is 28% of z, right? However, if the question would have been, tell me x is what percent less than z. If the question had been x is what percent less than z, then I've already calculated that x is 28% of z. So I can say that x is 100 minus 28, x is 72% less than z. It's 72% less than, or it's equivalent to 28%. They are one and the same thing, right? So this is how you can calculate these kind of questions. Let me take a quick recap here. So x is 40% of y. I can say x is equal to 2 by 5 y. Y is 70% of z. I can say x is equal to 2 by 5. 70 by 100 of z. I just use the value of y into this equation over here. Then I calculated that x is equal to 7 by 25 of z. So x is equal to 7 by 25 of z, and converting that into percentage, I got my percentage to be 28%. So I got my answer to be 28%. However, if anyone would have asked me that x is what percent less than y, since it is 28%, if x is what percent less than z, if x is 28% of z, that means that x would be 72% less than c, right? So I hope you all understood this question over here. So let's just move to the equations, right? So now I have completed the concept. I'm just trying to show the different type of questions that can be made, the general type of questions which come usually in exams. Now let's see this question over here. Now P is equal to A into B. A increases by 20%. By what percent should B decrease to keep the product constant? See, most of you will be saying, okay, if A increases by 20%, B also should decrease by 20% so that the product remains constant. However, that approach is wrong. Now let's see how is that approach wrong. Now P is equal to A into B, right? Now A increases by 20%. That means that if A has increased by 20%, that means that A will get multiplied by 1 plus 20 by 100, right? Which is equivalent to, if you calculate it, 6 by 5. So A has been increased by 20%. That means that A has got multiplied by 6 by 5. Now to keep the product constant, we have to multiply B by 5 by 6 so that whenever it cancels, we have this as constant. So B is going from B to 5 by 6B, right? So B is going from B to 5 by 6B. Now I have to calculate the percent change in B. Now guys, remember this, how do we calculate the percent change? It is very important. So the percent change can be calculated as the final value minus the initial value divided by the initial value into 100, right? So this will be into 100. So percent change is calculated as final value minus the initial value divided by the initial value into 100. So B came from B and became 5 by 6B. So that means my final value minus the initial value, that is the change that has happened in B, that is equal to B minus 5 by 6B, that is equal to B by 6. So final value minus initial value is B by 6. And if I have to calculate the percent change, I just divide B by 6 by the initial value, which is here as B into 100, right? So simply you can see over here, B and B get cancelled. So 100 by 6, guys, again if you refer to your textbooks, it's 16.66%. So I hope you understood. Let me take a quick recap here. P is equal to A into B. If A increases by 20%, by what percent should B decrease to keep the product constant? So P is equal to A into B. If A gets increased by 20%, it gets multiplied by 6 by 5. That means B has to get multiplied by 5 by 6. Getting multiplied by 5 by 6 means that decreasing by 1 by 6, which is equivalent to 16.66%. Why I have done this whole steps, these number of steps is to explain you the concept. However, you do not need to do it over and over again. Simply, B became B, 5 by 6 B from B. That means it reduced by 1 by 6. That is equivalent to 16.66%, right? So I hope everyone understood this. Now let's just come down to our last point, that is compound increase. This is the kind of percentage increase which you face in compound interest and in population increases, right? So a population of a town X increases, it's 10,000 in the year 2012 and increases by 10% every year. And what will be the population of town X in 2014, right? So the population of town X is 10,000 now in 2012. So let me just denote the population by P. So P in 2012 is equal to 10,000. So P in 2013 is going to increase the population by 10%. So that means the population of 2012 will get multiplied by 1 by 10 and I'll get the population of 2012. I'll get the population of 2013. Similarly, if I want to calculate the population of 2014, again this value will increase by 10% and I'll get my answer to be 1 plus 10 by 100 into P of 2013, right? So I hope everyone understood there. I just did some simple steps that every year the population increases by 10%. That means every year the population gets multiplied by this number over here, right? So instead of calculating every time that it gets increases by 10%, it should get multiplied by this number since the percentage is same. I can simply say in 2 years, this number over here is going to get, if the gap is of 2 years from 2012 to 2014, the gap is of 2 years. So my population in 2012 is going to get multiplied by this number 2 times. That means the square of this number, right? So I can easily calculate the population in 2014. What if someone says, okay, X was the population, or X is a number that is in 2012 and it increases by 10% every year. Tell me what will be the population in 2022. So it's simple. Since the gap is of 10 years, the population in 2022 will be given by the population of 2012 times the integrating factor divided by, raised to the power, how many number of years, guys? There are 10 number of years. Okay. So in the end, I can generalize this as that the product, in case of compound increase, that means it's constantly increasing by a specific percentage after a constant duration of time, that is equal to x, that is the base, into 1 plus r by 100, the rate of increase raised to the power the number of times it is going to increase, right? So this is the generalization of the compound increase. You get these kind of problems in compound interest. We're going to explore the compound interest in the interest chapter. So I hope you all understood this. This was the concept that you all need to know in case of percentage topic, right? So percentage topic, it's a very simple topic. However, we need a lot of practice to learn that, to understand all the scenarios. So this is the compound increase. We have done the equations, we have done few statement drafts, we have done so what you need to understand, what you need to learn is these three types of statements, that x is what percent of y, right? And x is what percent of y, x is what percent more than y, x is what percent less than y, right? So these are the three types of statements that usually keeps on revolving around, and in the end it's practice that all matters, right? So what I would recommend is, I would thank you for your patience for viewing all that video. So do not forget to watch the practice video on percentages, where I'll be solving a lot of questions, and this is going to be my email address, and my name is Pushpinder Gill. And do not forget to like me on Facebook. This just click on here, you'll go to the Facebook page, where I keep uploading, keep giving questions every day, some new vocabulary words and all that. So this is a free resource. Please go ahead and use it, and do not forget to share it with your friends. So thank you very much, and see you next video.